Well, happy Wednesday, everybody. Hope everybody's having a good week. So, here we are, last lesson, per se, of the week, and it's going to be on kites. So, what I'd like for y'all to do is draw this shape on your notes, and I'm going to talk about where the word kite actually came from. Well, the Chinese were actually the first country to uh, create or develop the flying kite. And theirs were more of a box kind of shape where the air would come through it, and they could actually fly in the air, especially on a windy day. Well, somebody came along and made this design right here, and put a little tail to it, with the like little ribbons or whatever that ties to it, and then they tied a string to the two poles that connected the material together, and they flew it. So they used that term, oh, you're flying a kite. And so since the flying kite came first and somebody created a shape that they flew, they decided to call this shape a kite. And that's where that name comes from. Now, a kite is a quadrilateral that has two pair of congruent consecutive sides. So everybody put a tick here and a here. These are consecutive. They are congruent. And then the second pair, put a double and a double. These two are congruent. They are consecutive. So therefore, this makes a kite. Now, because the kite has two intersecting segments, we do have a situation where these are not congruent. So this diagonal and this diagonal are not congruent, but one set will be bisected. So everybody put 3 and 3. So you'll have one set that is congruent, but the other two will not be congruent. Excuse me. Now, the two segments that do cross each other will form 4 right angles. So this is going to be just like yesterday when we talked, or actually I think it was Monday. Monday we talked about how a square and a rhombus has intersecting diagonals that form 4 right angles. So does the kite. So that means you could use trig and or the Pythagorean theorem. So always be on the watch out because we have 4 right triangles. All right, there's some other things that's going on with our diagram. And here is the next thing. These angles are being bisected. So everybody put an angle mark here and here. These two are bisected. These two are bisected along with these two. I'm sorry, they're not bisected. These two are bisected here and here, but these will not be congruent. So let's go 3 and 4, 3 and 4. There you go. Wow, a lot of things going on. Now, here is one of the most important things you need to know about the kite. I call these two parts of the kite the wings. It's like the flaps or the wings of the kite. Well, if I was to measure this angle and this angle, I'm talking about the whole thing. Notice we got 3, 4, 3, 4. That means 3 and 4 and 3 and 4, they're equal. So these two will be congruent. For instance, if this was 100 degrees, that would be 100 degrees. Now the top and the bottom will not be congruent because look, we have a 1, 1, 2, 2. Just be careful. Some kites are drawn like this. Some kites are drawn like this. So they don't have to be perfect and pretty just like so. Now that we have all this, the main thing you need to know, we're not going to be using 180 on some of these problems. It's actually going to be 360. Okay, because you know in a kite is a quadrilateral. A quadrilateral, 4 sides, means that all the angles add up to 360. So you're going to have some scenarios with these angles that sometimes students get confused about, but instead of using 180, we're going to use 360. So let me show you what I am talking about. All right, let's just go ahead and make a quick kite here. And we'll say this is 110 degrees. This is 100 degrees. And I want us to find X. Well, because these are the wings of the kite, you can automatically put this number in. And then that's where the 360 comes in. So you go 360 minus 100 minus 110 minus 110. So 360 minus 100 minus 110 minus 110 would give you 40 degrees. All right, another way they could do this, they might say this is 50 degrees, 110 degrees, but what is X? Well, if you take 360 minus 110 minus 50, you get 200 degrees. Now, this 200 means it's got to be split between these two because we know these two are congruent. So if I take 200 divided by 2, I would get 100. So that's another scenario that you could see in this situation. Also, let's go back to this triangle here. If this is 100 and we'll say that this is 60, then you could say 100 minus 60, which would give you 40. And if this is 90, 90 minus 40, and that would give you 50. So just keep in mind that you could be breaking some of these apart in some of the problems that we're going to see. All right, let's do real quick one that might deal with some of the segments that are inside of the picture. So y'all go ahead and draw this in. All right, we're going to say this is 6. We'll say this is 7. And I want to find X. And I want to find, we'll call this angle ABC. Okay, so first let's find X. Oh, look, we have a right triangle, a side, and we're looking for a side. So we're going to do the Pythagorean theorem. A squared plus B squared is equal to C squared. 36 plus X squared is 49, minus 36 is 13. Now let's use our calculators to find the square root of 13. So 13 square root 3.6. So X is 3.6. Notice I didn't draw that scale. All right, so that's how you would find like a side. You might have to use trig on it. I'm sorry, Pythagorean theorem. Oh, let's talk about trig because look what I'm looking for next. angle ABC. Oh, I need to give y'all something else, don't I? No, I don't. No, I don't. We have everything we need. So here is angle ABC. And what I'm going to do is I'm going to figure out what that angle is because I have a right triangle. And I'm going to use these numbers since 3.6 is rounded. I have an O over H. So inverse sine O over H. Okay, so let's put this in our calculator. If you're using your cell phones, 6 divided by 7 is this. And now we're going to go second sine. 58.99 or 59 degrees. So if y is 59 degrees, right here, angle ABC, looking at our diagram, shows that these two are congruent. So 59 times 2 would be 118 degrees. And that would be the whole measure of this angle. So a lot of different things that you can do with the kite. One other thing I need to remind you, because I think it's on your forms today, it's going to ask for perimeter of the kite. So remember, you have to add up all the sides. And you only need 2 numbers. If you have a number here, and let's say a number here, you know these two are the same, these two are the same, add it up. You might have to do Pythagorean theorem, you might have to do trig, or they might just have everything necessary in order to find it. Okay, take your time. If you need to ask someone in your class, you know, hey, I don't understand, see if somebody can help you out with it, and that'll be it. Now, tomorrow, I'll go ahead and warn you right now, instead of doing a whole complete new video, I went back to last year, so you're going to see a recording of a test review of what we just did these last 3 days that I'm going to upload to your teams, and watch it, take down the notes, write down the examples. If you do that, then you should have no trouble whatsoever on getting or doing well on your test for Friday. If I'm here Friday, I will give you the test myself. If not, you'll be doing it on School City. All right. Good luck, everybody. See you later.